Hello everyone. Today we're going to discuss about Bernoulli and binomial distribution. Bernoulli distribution is a discrete distribution having two possible outcomes, whether success or failure in a trial. And the formula for Bernoulli distribution is next, binomial distribution. The definition of binomial distribution is repeat a Bernoulli P experiment for n times and count the number x of success. The distribution of x is called the binomial B and P random variable. The formula for this distribution is this formula works for any random variable that counts the number of times an event occurs out of n trials, provided that following assumptions are met. The first one is the probability that event occurs P must be the same from trial to trial. Second, the trial must be independent, and the last one is the number of trials n must be fixed in advance.
Use or application of the distribution in real-life situation. Biology application. Some biological processes seem to be directly affected by chance outcomes such as formation of gametes, recombination events, and occurrence of genetic mutations. Design many experiments such as random allocation of treatments or the random sampling of individuals. Engineering application. Binomial distribution can be used to determine the probability of all possible outcomes in a system. Only a precise number of outcomes and their probabilities are usually of interest in engineering applications, for example, outcomes that lead to system failure.
This is one of the examples for this topic. Let's take a look. If 10% of pens manufactured by company are defective, find probability that a box containing 12 pens contain exactly 2 are defective pens and at least 2 are defective pens. Before we do the question, first we need to find the probability of success and probability of failure. Probability of success is represented by P. As we know, P is 10%. Also, it's 0.1. So probability of failure, we know that P plus Q equals to 1. And we so we need to find Q. Q is 1 minus P. As we know, P is 0.1. Therefore, 1 minus 0.1 equals to 0.9. So, the probability of success and failure we have found. Next, we need to find the value of n. From the question, we know that the value of n is 12. So, the value of n is 12. So, for the first questions, exactly 2 are defective pens. First, we need to do the formula. This is the formula for this topic. This is our random variable. From the questions, the random variables are 2 for the first question. So, when we apply to the formula, this is how we apply our random variable. Next, we put our value of n and value of random variables. The value of n is 12, and the value of x is 2. And the value of probability of success is 0.1 to the power of x, and that is 2. And the probability of failure is 0.9 to the power of n minus x, and that is to the power of 10. So when we do the solution, power of x, and that is 2. And the probability of failure is 0.9 to the power of n minus x, and that is to the power of 10. So when we do the solution, we get 0.23. That is our answer for the first question. Next, for the next question, we are asked to do at least 2 are defective pens. At least 2 are defective pens. We need to find P x equals to 2, P x equals to 3, and P x equals to 4, and so on. For the easy part, we only need to do P x greater or equal to 2. This is the easier way to do the probability. So what we need to do is 1 minus P x equals to 0 plus P x equals to 1. Next, we applied our formula. We get 12 and 0, and the probability of success is 0.1, to the power of x is 0, and the probability of failure is 0.9 to the power of n minus x, and that is 12. And for this part, we just need to do the same thing, and that is 12C1. And the probability of success is 0.1 to the power of x, and that is 1. And the probability of failure is 0.9 to the power of n minus x, and that is 11. So when we do this, we get 1 minus 0.282.
Assalamualaikum. Hi. Let's try this exercise. First of all, we have a random variable x, the distribution binomial 12b. And trial is 12. Probability of success is p. A, given that probability 0.25, and asked to find probability x less than 5, part 2, probability x more than and equal to 7. Probability x less than 5 is probability x 0, 1, 2, 3, 4 is exactly to p x less than and equal to 4. And we need to just look at our table. At n equal to 12, x equal to 4, and probability under 0.25 is 0.8424. So our answer is 0.8424. Okay, next, part 2, Px greater than and equal to 7 is exactly to 1 minus Px less than and equal to 6. So, Px less than and greater to 6, we need to use our table, binomial distribution table, and equal to n equal to 12, x equal to 6, and our probability under 0.25 is 0.9857. So our answer for part 2 is 0.0143. Okay, for B, given that P px equal to 0 is 0.05, and we need to find the value of probability to 3 decimal places. Okay, from the question B, we can get this info. N equal to 12, px equal to 0 is 0.05, and our q is 1 minus p, and we need to find our probability. And we also familiar with this binomial distribution formula, this one, and from this formula we need to substitute our value. Okay, so we can see that any 0 of c is 1, and any power of 0 is also 1. And we need to solve this question to get our p. And our answer is 0.221 in 3 decimal places.